Man will fly through the power of his mind, not through the strength of muscles. These words belong to a great Russian scientist, Nikolai Zhukovsky. Said at the end of the 19th century, they really forecast the future evolution of aviation. First, the power of man's mind lifted the aircraft off the ground. Then a Russian pilot, Pyotr Nesterov, having performed his famous loop-de-loop, proved that anywhere in the air there is a support for an aircraft. Man continued to fight the force of gravity. Fighter aircraft were flagships in this battle. These particular aircraft were often the first to reach never-before-seen boundaries. The designers and engineers always had to tackle new, more complicated tasks. Facing the challenges, they often had to compromise and give away one thing in favor of another. Speed in favor of maneuverability, flight range in favor of operational load. But in the 70s of the 20th century, the new aircraft that combined at first sight the incompatible features was created. This aircraft was the Su-27, a representative of the new combat aircraft era. Oleg Samylovich was one of the originators of this plane. He was the head of the Sukhoi Design Bureau Concept Department in the 70s. The book of Oleg Samylovich about his work at his famous design bureau was published in 1999. One of the book parts is totally dedicated to the creation of the Su-27. This part is called The Best Fighter in the World. We decided to give the same name to our film. Before proceeding with the story of the Su-27 creation, we would like to dwell on the technical competence of the scientists and aircraft engineers and the scope of problems they were facing when they started to develop the new generation fighters. By that time, the military aircraft had more than 50-year experience of combat flying. Military aircraft were assigned a specific mission during World War I. Originally, airplanes were used for air reconnaissance. A bird's-eye view of the enemy lines made them clearly visible. The next quite logical step was using aircraft for bomb dropping. Bombers became a real threat. This threat could be partly fought with anti-aircraft artillery. But small, biting like mosquitoes aircraft were much more efficient against bombers. This is how a special aircraft known as a fighter was born. To catch up with an enemy, a fighter aircraft has to fly faster. Speed is a major critical characteristic of a fighter aircraft. As soon as fighter-type aircraft emerged, most of the aerial combats became their privilege. Under such conditions, another important characteristic came to the fore: maneuverability. Speaking of fighters, it's an aircraft ability to place itself into a tactically advantageous position by means of fierce maneuvering in the air. Speed and maneuverability have always been principal characteristics of any fighter. A compromise between high speed and good maneuverability will be the main objective for aircraft designers. So what is the problem? Let's find out. The history of an aircraft is in many ways the history of its wing. As we know, a wing provides a lift force for an aircraft. For illustration purposes, let's study two aerodynamic layouts. One is a monoplane, an aircraft with one wing, and the other is a biplane, an aircraft with two wings. With the same size and weight, bigger wing area gives an aircraft better maneuverability. At the same time, bigger wing creates higher drag to an incoming airflow, thus reducing flight speed. It means that higher speed can be gained at the expense of maneuverability. In practice, the choice of an aircraft layout is affected by many factors. One of them is an aircraft's structural strength, but we cannot think of the Su-27 as a biplane aircraft now, though during World War I, biplane layout was used to provide aircraft structural strength. Another important aspect is engines. The first aircraft engines could accelerate an aircraft to the speed of only 200 kilometers per hour maximum. In the 30s, the 300 kilometers per hour barrier was broken, then 400 and 500. Powerful engines, canopy cockpits, retractable landing gear, and finally monoplane layout were the attributes of high-speed fighters at the end of the 30s. Another critical test for military aviation was World War II. By that time, the monoplane fighters reigned in the air. Designers were looking for a compromise between speed and maneuverability within monoplane layout only. Aircraft outlines became more refined. The flight speed increased and it exceeded 700 kilometers per hour. That was the maximum piston engine fighters could achieve. Their era was coming to an end. The future was for jet engines. The young Boy Scouts are studying the new aerodynamics basics by watching this jet aircraft model. The small jet plane held by two steel cords is flying in circles with high speed. The new engines gave enormous opportunities for further developments. But as in the case with this model flying in circles, the two steel cords were preventing it from free flight. The new barrier was holding fighters' speed back. The problem was an aircraft wing again. With the speed going up, the air drag increases. It can be compared to an invisible spring compressing in front of an aircraft. At speed close to the speed of sound, the air becomes as solid as a wall. To get over this drag, a simple increase of engine thrust is not enough. It's necessary to significantly improve aircraft aerodynamics. Wing airfoil section was changed. A wing became thinner and swept. The speed issue was under intensive consideration again. 1,000, 1,100, 1,200 kilometers per hour, the sound barrier was broken. Engine thrust was increasing. Afterburners were developed. The flight speed was getting higher. The wings were continuously sweeping back. At the same time, wing loading was increasing. Fighters with a wing sweep angle of 60 degrees were the highlight of these developments. They were able to achieve double the speed of sound. Again and again, the critical speed issue is under consideration. But what about such an important fighter parameter as maneuverability? The maneuverability seemed to have been forgotten. In a way, it was true. To be more precise, it was not forgotten, but conscientiously sacrificed. In the mid-50s, they began to equip aircraft with air-to-air missiles. According to a new theory, aircraft could launch their missiles to attack each other from a long distance without engaging in close maneuver air combat. Fighters were treated as a specific platform to deliver and launch missiles. In America, one of the missiles called Genie was equipped with a nuclear charge. The designers intended this missile to explode in the air and burn to ashes every aircraft within a radius of several hundred meters. This missile wasn't used in real combat action. Moreover, the theory of aerial long-distance missile engagement didn't appear to be very successful. The war in Vietnam put it all into place. During the war, it was realized that shooting down an aircraft from a long distance was not always a success, and the aircraft got engaged in close combat conducted at subsonic speed. Quite often, the outdated MiG-17 was a winner against the latest supersonic but less maneuverable Phantom. It turned out that an aircraft could dodge attacking missiles using the so-called missile-avoiding maneuver. An aircraft could suddenly change its flight path, which a missile of those days couldn't do. Both the USSR and the US researchers came to a similar conclusion. A new fighter was needed, a fighter that could fly at high supersonic speed if required, and to steadily conduct a subsonic aerial combat. Which way to go? What aircraft type to choose? What concept to implement in the aircraft building? Those were very urgent issues to consider. We started a conceptual research on what aircraft had to be built. Everybody were convinced that a good maneuver was extremely important, since it is an aircraft maneuverability that plays a key role in aerial combat. So the problem was to develop highly maneuverable aircraft.
Возникла проблема создания самолета высокой маневренности.
There was another problem. A highly swept wing was low efficient at takeoff and landing. As a result, the takeoff and landing run was too long, and long runways were good targets for an enemy. Also, an aircraft may crash if its landing speed is too high. In the 60s, a new wing was implemented. It was a variable swept wing. Soon they started building combat aircraft with such a wing, both in the States and the Soviet Union. With a highly swept wing, an aircraft was able to perform a supersonic flight. With a mid-set wing, an aircraft could conduct an aerial combat. A straight wing significantly improved aircraft takeoff and landing performance. A variable swept wing was believed to be able to solve the problem. But this wing was somehow a link between past and future, a step toward new developments. A variable sweep wing was a good idea, but its designers had to pay a high price. Through the implantation of a variable swept wing, an aircraft weight was significantly increased. To make the next step forward, another solution, simple in shape and elegant in concept, had to be found. This very solution was implemented on the Su-27 aircraft. The general conception of the fourth-generation jet fighter was expected to use medium swept wing with a low wing loading. This was a way to improve maneuvering and takeoff and landing performance. So did the compromise aircraft high speed to its high maneuverability? Of course not. New generation engines allowed to achieve double the speed of sound, even with such a wing. This was a completely new approach to aerodynamics research, significant progress in engine building, a new fighter control system. Almost every field of aviation had its breakthrough. However, we are a bit ahead of time. Tactical specification requirement on advanced frontline fighter was issued in 1971. The tender to develop a new fighter was shared between 3 design bureaus. These were Yakovlev, Mikoyan, and Sukhoi design bureaus. Till now, we were considering a fighter primarily as a flying vehicle. A fighter must definitely have a good flight performance, but this is obviously not enough. In order to become a superior combat system, a fighter needs up-to-date onboard equipment, armament, and many other things. It was a fighter updating where Pavel Sukhoi saw some problems. The general designer doubted that the Soviet electronics industry could provide up-to-date equipment for a new fighter. At that time, Soviet electronic equipment was quite heavy and big. The heavier electronic equipment is the heavier an aircraft is. In such a situation, to achieve required flight performance was far more difficult. It was also known that the American new generation fighter was already under development. The Soviet Union was behind the States in this race. It was necessary to design a fighter with the characteristic different from an American rival, so that it would be superior to enemy aircraft. It was that time that such a specific term as air superiority fighter appeared. A bench for two-fighter aerial combat was built for that purpose at our institute. The bench comprised two moving cockpits with all 3 degrees of freedom, though it was kind of conventional. However, the horizon was rolling and turning depending on all aircraft maneuvers and emergence of an enemy aircraft. According to the specification requirement issued by the militaries, the Soviet fighter characteristics had to be 10–15% higher than those of a new American fighter. It was also pointed out that to increase combat survivability of the new Soviet fighter, it had to be a 2-engine aircraft. At that time, the Soviet Air Force Commander-in-Chief was Marshal Kutakhov, and his deputy in weaponry was Colonel General Mishuk. Mr. Mishuk was a very experienced aircraft engineer. He served in the Army during World War II and was an educated and competent officer. Marshal Kutakhov was a combat pilot, here of the Soviet Union. He was always interested in technical aspects. He regularly attended meetings at the Ministry of Aviation Industry. He also visited the Institute very often to meet with our general designers. I remember he used to call us once a month and asked, "Well, science man, have you got any news?" The military people treated us very well. They had a big stake in the 4th-generation fighter concept. In those times, a lot of money was spent on aviation projects. The country leaders, headed by Leonid Brezhnev, spared no expense on aircraft and other military projects. The Communist Party leader was looking at displayed combat equipment with evident pleasure and genuine interest. It was common practice for leading aviation designers and military command authorities to participate in such displays. Pavel Sukhoi, wearing his famous hat, is on the left from Leonid Brezhnev. Pavel Sukhoi started his aviation career at the Central Hydroaerodynamic Institute, where he worked under direction of Andrei Tupolev since 1925. With his direct involvement, Pavel Sukhoi designed I-4, the first Soviet all-metal fighter, and I-14, the world's first high-speed monoplane fighter with retractable landing gear. The Sukhoi Design Bureau became independent in 1939. This year, mass production of the BB-1 short-range bomber designed by Sukhoi was started. In 1940, this bomber was named Su-2, and it became the first aircraft which received the famous Su name. Since that time on, combat aviation is inconceivable without Sukhoi aircraft. In the 60s, fighter aircraft designing was a real success for the Sukhoi Design Bureau. These were the aircraft of 2 types: fighter interceptor and fighter bomber. It was the Su-27 fighter bomber that became the first Soviet variable sweep wing aircraft. Another interesting subject matter in the Design Bureau from the early 60s was creation of the T-4 Sukhoi aircraft. Creation of this aircraft allowed moving to quite a new level of all the Sukhoi Design Bureau activity, despite the fact that the aircraft was not put into mass production and the project was stopped in the mid-70s. However, this project laid the scientific and technical groundwork that was successfully used later on in creation of the new generation aircraft, including the Su-27. In March 1971, the meeting of Aviation Ministry Scientific and Technical Council took place. At this meeting, 3 design bureaus presented their groundwork on the new advanced fighter. The Yakovlev and Mikoyan projects outwardly looked like the previous aircraft they built. But Sukhoi presented something new. That was a project of the future Su-27. Research work on this aircraft was started in 1969. The originator of the project was Oleg Samylovich, who worked in the Design Bureau Concept Department. By that time, he took part in such projects as the T-4 long-range missile carrier and the Su-24 frontline bomber and the Su-25 attacker. Now, it was a new aircraft turn. The designers had to place the emphasis on the integral layout of the future fighter. The Su-27 also started with Oleg Samylovich. One winter Sunday in 1970, the aircraft layout was created with his hand. On that Sunday, Antonov, Samylovich, and me were working in the office. A day before, on Saturday, Bondarenko was there. All of us wanted to consolidate the achievements made by the team at that time, mainly on Antonov's drawing board. There's a profession dealing with the aircraft pre-designing. This is a work on an aircraft when it is not yet available. Samylovich liked to say, what is designing? Is it a science or art? It is both a science and an art. The success of an aircraft design is in fact the status of its designing school. I was lucky to be the person whose drawing board had that aircraft drawn upon it. It's true, but on the other hand, all personnel were behind my back, so to say. Many people from the staff contributed their thoughts to this aircraft and its elements. There is no doubt it was an exciting time. Being young specialists, then we were mainly impressed with the faith they had in our capabilities to work on such overwhelming projects. There were older friends who treated us as their equals, or it might have seemed to us. On the other hand, youth is the best time for everyone. I have the best recollections of that time. After the wind tunnel tests of these models, upon receiving positive results, Oleg Samylovich said, Vladimir, let's go to Sukhoi. Sukhoi rose from his seat near the table, shook my hand, and gave me a paper where it was written that Vladimir Antonov, designer-engineer of the second category, was awarded the first category with a salary of 185 rubles. The most interesting were the words that Sukhoi said. Young man, you've done a lot of work, but you have to understand that this is a part of the work being done in the country to conquer this peak, to develop the fourth generation fighter. So what's the feature of the layout that the designers offered? Let's have a go at this problem. To fly up in the air, an aircraft needs a lift force. A wing plays a key role in this process. There are some specific ways to create a lift force on the wing. These are use of special airfoil section and an increase of an angle of attack. The angle of attack is the angle at which a wing meets an airflow. In these airflow conditions, air pressure under a wing is higher than above it. This pressure difference creates a lift force on the wing. But what about other parts of an aircraft? Do they create a lift force? What about a fuselage? On most aircraft, fuselage creates a minimum lift force. Is it possible to change the situation? It appeared so. The Su-27 designer used airfoil sections to build other structural parts of an aircraft, not only a wing. It would be no exaggeration to say that the whole aircraft became a lift surface. A wing root glove played a large role in creating lift force. But initially, the designers could not see all the advantages of such technical innovation. They thought of a wing root glove as a method to improve aircraft stability at supersonic speed. Only after an enormous amount of wind tunnel tests, the designers realized new advantages of the wing root glove. We had a wonderful guy, Kurichkin, from Roman Irodov's department, who discovered one very interesting effect. If the wing root glove is made pointed, which means that the tip is sharp, a very powerful vortex was induced with this sharp tip. This effect made it possible to increase lift force by at least 50%. Pointed wing root glove transforms an airflow into a powerful air vortex. A vortex creates a stable vacuum zone above the wing. Differential pressure grows, causing a significant increase of lift force. With an angle of attack increase, the vortex intensity grows. This allows an aircraft to fly at higher angles of attack without losing its stability or stalling into a spin. This directly leads to higher maneuverability. For example, a turn or a combat turn can be performed more aggressively. During such maneuvers, the vortex intensity is so big that a vortex can be seen with the naked eye. It's time to have a look at what was happening with the new American fighter. In July 1972, the aircraft called F-15 Eagle performed its first flight. The F-15 had a traditional layout. Therefore, the Su-27 aerodynamic layout had advantages and was expected to be superior to the U.S. fighter. But Su-27 had to meet a competition in the USSR first. The choice had to be made between the Yak-45, MiG-29, and Su-27. It's worth mentioning that the Sukhoi Design Bureau presented another project of a fighter with traditional layout. The Sukhoi designers preferred their new layout to the traditional one, but they couldn't predict the opinion of the military authorities on the issue. But the future of the new layout was so promising that at the next stage of the tender, the MiG-29 took a new shape. It's worth stressing that it was planned to choose only one project. But later, some essential correction and changes were made into the plan. This situation somehow looked similar to the one they had in the US. Designing their F-15 aircraft, the Americans realized that sometimes it was not reasonable to use such an expensive aircraft. Therefore, in addition to the F-15, it was decided to develop an aircraft which would be cheaper and lighter. In future, this aircraft will be known as the F-16. In the Soviet Union, the concept of an advanced fighter was also revised. Eventually, the Mikoyan Design Bureau had to develop a lightweight fighter. Heavy fighter development was the task for the Sukhoi Bureau. As for the Yakovlev Design Bureau, they didn't participate in this tender any longer. The decision to design two different fighters was quite logical. It wasn't copying of the American conception at all. In the USSR, they conducted certain research on this issue. The results were nearly the same. Lightweight fighters such as the MiG-29 were required to provide air defense over a battlefield. Heavy fighters like the Su-27 had to win air superiority operating over enemy territories. That would ensure successful combat mission of a frontline attack aircrafter. It's worth mentioning that in the process of the aircraft building, the question whether we were right in our decision for the two aircraft types was continuously emerging. By the time when Dmitry Ustinov became Minister of Defense, he raised this issue at the moment when we were on the state flight tests. Anyway, we stood this strong administrative pressure and proved that it was necessary to build two aircraft. They were the MiG-29 and the Su-27. In 1974, Naum Chernyakov was appointed the aircraft chief designer. At that time, the name Su-27 was classified, and the aircraft was developed under T-10 designation. From the early 70s, a lot of tests and experiments were conducted under this project. These included wind tunnel simulation, tests on full-scale flying models, test bed for the aircraft systems development, and many others. The Soviet leading aviation institutes were also involved in this project. With the development of Soviet aviation, more companies and enterprises became involved in the new aircraft creation process. Among those were different design bureaus and research organizations of various trends. Speaking about that time, it was normal and very intensive work. I can't say that it was easy, as it was very intense, but quite normal work to do. When we first saw the T-10-1 aircraft mock-up, we were very much impressed with its unusualness, aerodynamic configuration, and with all of its shape. The aircraft looked like a bird. Without any exaggeration, I would say in those years I was looking forward to a new working day, because it was interesting to work. Now there is some talk about stagnation period. Stagnation might have been somewhere, but in the defense industry, we were in the state of war. We worked under wartime schedule. That was an epoch when employees of the defense industries were leaders and were supported, including financial support first. There were some difficult situations, however. We were not pushed and beaten, but were given help to set something right. That was a great era. The objective was clear. The Soviet fighter had to be better than the American one. Soviet better than American was sort of official slogan in the USSR. Now let's go back to the 70s. The Olympic Games in Munich in 1972. The Soviet athletes had a goal to win 50 gold medals and to outstrip the Americans of this competition. No sooner said than done. The Soviets won 50 gold medals. Those victories were unforgettable. The USSR men's basketball team won their first Olympic gold medals by beating the US team in a challenging and dramatic game. Athlete Valery Borisov won 100 meters and 200-meter runs and cut short domination of American sprinters. The Soviet power must be kept high. In 1975, everything was ready to build prototype aircraft. In 1976, the Council of Ministers of the USSR issued a corresponding decree. In spring 1977, the first T-10 prototype was ready for flight tests. Unfortunately, Pavel Sukhoi didn't live to the moment to see the aircraft completely built. On September 15, 1975, this outstanding designer passed away. His close associate, Yevgeny Ivanov, took over. Here is the video of Tushino Air Parade in 1948. Pavel Sukhoi is in the middle. Yevgeny Ivanov is on the left. The Su-27 chief designer was also replaced. In 1976, this position was taken over by Mikhail Simonov. May 20th, 1977. Flight Research Institute Airfield in Zhukovsky. The test pilot Vladimir Ilyushin is getting ready to take the new fighter up into the sky. Vladimir Ilyushin is hero of the Soviet Union, the Sukhoi Design Bureau senior test pilot, and a son of the famous Soviet aircraft designer. He tested many Sukhoi aircraft before that flight. Had he got a feeling that this aircraft would become one of the best fighters in the world? Before this aircraft, I flew 142 modifications of different aircraft. I always had a feeling that I was a kind of smarter than the machine, capable of doing more than it could. But the things were quite different on that 143rd. It proved to be smarter than I was. As soon as the aircraft took off from the concrete, taking the aircraft into the air for the first time, I realized that this aircraft could do more than the pilot. To make full use of its wonderful capabilities, it's necessary to improve my skills. It was an aircraft that could be awaited all life long. For the sake of this aircraft, it was worth becoming a pilot. But it was a very long way to make this aircraft the best world's fighter. By the time of the first test flight, despite all the technical innovations, it was evident that this aircraft could not be superior to its American rival. The F-15 already showed its potential. In 1975, the specially arranged aircraft set several rate-of-climb world records. During the Su-27 development, it became obvious that the aircraft would be too heavy. Its weight characteristics were exceeded because of heavy electronic equipment. Pavel Sukhoi was right when he doubted that electronics industry could provide up-to-date equipment. Missile armament designers also fell outside the limits. The engines were only in development stage, but it was clear that they could consume more fuel than expected, and therefore more fuel will be required on board the aircraft. There were also problems with the aircraft aerodynamic parameters. During the first flight test, it turned out that angles of attack higher than 10, the aircraft started to shake. In such a situation, it was useless to talk about the Soviet fighter superiority.